Good morning, student. Today we'll discuss about the synchros. Synchro is an electromechanical transducer that is used to convert the angular shaft position into the electrical signal. Okay, so the basic elements of synchro is a synchro transmitter whose construction is similar to the three-phase alternator. The stator, which is stationary, is of laminated silicon steel and is slotted to accommodate a balanced three-phase winding, which is of the concentric coil type, in which the three identical coils are placed in the stator with their axes 120-degree apart, and it is star connected. The rotor is of dumbbell shape. It is of dumbbell construction and it is wound with a concentric coil. Through the slip ring, AC voltage is applied to the rotor winding. So this is, we can say, the constructional feature of the synchro transmitter. Here it is a rotor and the stator is there. Okay, and these are the slip ring. AC voltage is applied to the slip ring, to this rotor through the slip rings. This is the inner periphery of the stators. Inner, this is a slotted in these three windings, three-phase windings is housed in this slotted, and this is the rotors. Now the constructional features of this synchro transmitter is very similar to the three-phase alternator. So let the AC voltage is applied. The AC voltage is applied of VRT is equal to VR sin omega CT. So this much of voltage is applied to the rotor of the synchro transmitters. Okay, and when this voltage is applied, this will cause flow of the magnetizing current. When this voltage is applied through the slip ring to the rotors, this would cause a flow of magnetizing current in the rotor coils, which produces the sinusoidally time varying flux. And this sinusoidal time varying flux is directed along its axis and is distributed nearly sinusoidally in the air gap between the stator and rotor. And because of transformer action, the voltage is induced in these three stator coils. And as the air gap is sinusoidally distributed, the flux linking with any stator coil is proportional to the cosine of the angle between the rotor and the stator coils. Okay, and therefore the voltage induced in the stator coil, the stator coil voltage are in time phase with each other. Therefore, we can say that the synchro transmitter acts like the single phase transformer in which the rotor coil is the primary winding and the stator coil is of three-phase secondary winding. So this is the, we can say, schematic diagram of synchro transmitter. This is the schematic diagram of the synchro transmitter. Here the rotor is there. We have to give the AC input supply to this rotor. These are the coil S1, this S2 and this S3. And this is the reference position of the rotor. And this reference position of the rotor makes an angle theta with this coil S2. This makes an angle of 120-degree plus theta with the coil S1. This axis makes an angle of 240-degree plus theta with S3. So this is for the sake of the explanation, we will consider this as a reference position of the rotor. So let us, the three voltages, when you apply this AC voltage, let VS1, VS2, VS3 be the voltage induced in the stator coils S1, S2 and S3 with respect to the neutral, and therefore VS1 as the voltage induced in the coil VS1 as there is angle of 120-degree plus theta, therefore VS1 is equal to KVR sin omega CT into cos of theta plus 120-degree. Similarly, the VS2, which makes an angle of theta with the reference position of the rotor, therefore voltage induced CMF in the coil S2 is equal to KVR sin omega CT into cos theta. Similarly, VS3, which makes an angle of theta plus 240-degree with the reference coil we have considered. So this is the voltage induced in these three coils We'll give the name to this 2, 3, and 4 equation. And now we have to find the terminal voltage of the stator. Okay, so the voltage between the terminal S1 and S2 can be calculated just by taking the difference of this voltage induced EMF in the coil S1 and S2. If you find, we'll get this is the voltage induced in the terminal S1 and S2. This is the voltage induced EMF in the terminal S2 and S3. This is the voltage induced EMF in the terminal VS3 and S1. So this is equation number 4, 5, and 6. So now when suppose when theta is equal to 0, theta is equal to 0 means this rotor will be in position with this stator coil axis. Rotor axis will be in position with the stator coil axis, and therefore this, if theta is equal to 0, this will tilt and it will make an angle of theta is equal to 0. If theta is equal to 0, we can say in equation number 3 to 5. If theta is equal to, in equation number 3 to 5, what will be the value? Theta is equal to 0. So this will be the VS2. So we'll get the maximum voltage induced EMF in the coil, stator coil S2 when theta is equal to 0. And the terminal voltage VS3 S1, this will become 0. VS3 S1, this will become 0. Okay. So this is called the electrical zero position of the synchro transmitter. When the theta is equal to 0, we'll get the maximum induced EMF in the coil S2, and the terminal voltage VS3 S1 will be 0, and this is called as the electrical zero position of the synchro transmitter. Now let us now see about the synchro as an error detector. When the synchro as an error detector, we can see here this is a synchro transmitter. This is the control transformer. The output of synchro transmitter is connected to the synchro control transformer. AC voltage is applied to this rotor of the stator coils. Here the voltage will induce in the stator coils. The induced voltage of the stator coils is again given to the synchro control transformer, and again the transformer action, the voltage is further induced in the rotor of the control transformers, and we'll get the induced CMF in the control transformer. So the induced EMF in the control transformer is, which is given by this equation, E of t is equal to K dash VR cos phi plus sin omega ct, and where this phi is the angular displacement between the two rotors. Phi is the angular displacement between the two rotors. And now when the phi is equal to 90 degree here, then the two rotors, they are at right angles to each other. And when they are right angles to each other, then we'll get the voltage induced is equal to 0. And this is known as the electrical zero position of the synchro transmitter. This will be known as the electrical zero position of the synchro transmitter. And this is all about the synchro as an error detector. Thank you very much for watching the video.